Hello, my dear students. Welcome back to Dr. Maran's Chemistry Academy. As we already seen how the ammonium ion shapes looks like, and now we're going to continue with the rest three of the polyatomic ions. So I'm going to show you how does boron tetrahydride looks like. Okay, exactly the concept is same. We're going to pull out the central atom, which is the boron. Okay, we're going to look into the what is the group of boron, right? So boron comes under group 13 and the valence electron is 3. So we're going to look into it has 3 valence electron. And as for hydrogen atom, we have 4 hydrogen atom, right? So we're going to put 4 hydrogen atom. And please bear in mind that I did mention earlier in my previous session that for any atom bonded, side atom bonded to the central atom, always remember we need to consider the valency, not the valence electron. So the valency for hydrogen to achieve duplet is 1 electron, but we have 4 electron times 1 electron, it gives you 4 electron in total. And of course the charge here, the negative charge signifies the electron added to the molecule. So since it is -1, meaning it is 1 electron being added, so we need to plus 1 electron because it is being added to the molecule. So when we total up the entire number of electrons, it will be 3 plus 4, 7, 7 plus 1, it will be 8 electron. Again, we're going to put it into the pairs of electron, it will be 4 pairs of electron. Right? It will be 4 pairs of electron. And immediately we can refer the table, or you can memorize the table. Right? It is very straightforward. If 4 pairs of electron, it comes under tetrahedral geometry, right? Tetrahedral. And we need to make sure that there is no lone pair of electron, because when there is a lone pair of electron, it will affect the molecular shapes, okay? Which maybe we're going to see some other molecules later. Right now it's 4 pairs of electron, no lone pair, it comes under tetrahedral shape again. So the tetrahedral shape is similar to what we have seen earlier, right? It will be 4 atoms of hydrogen bonded to the central atom boron with a negative charge, right? With a negative charge. So this is the tetrahedral shapes. Now we're going to go into the next molecular shapes, which is triiodide ion, right? Triiodide ion. So I'm going to erase this triiodide ion. So let's look into the triiodide ion. Okay, triiodide ion, again 1 central atom, and we have 2 other iodine atom bonded to 1 central iodine. So again the principle is same. 1 central atom, we need to look for the valence electron. So since iodine belongs to halogen, it has 7 valence electron, right? 7 valence electron, and you after minus the central you have 2 iodine, right? 2 iodine. And these 2 iodine valency is 1, right? It has valency 1. So that means we are not going to look into the valence anymore, okay? The 2 other side atoms, we need to find the valency. That means each iodine requires 1 electron to become octet, right? So we have 2 atoms of iodine, that means we're going to take 2 multiply by 1 electron. So this is going to give you 2 electrons in total, alright? And the third, you have a negative charge in the molecule. As I mentioned earlier, the negative charge means electron being added. So when electron being added, you need to plus that 1 electron, right? And we're going to total up everything. 7 plus 2, 9. 9 plus 1, we have 10 electron in total. And we're going to break it into pairs. So 10 electron will make it 5 pairs of electron. So we already get the concept, the whole idea, right? So 5 pairs of electron, we're going to find out triiodide molecules comes under which molecular geometry? So it comes under the trigonal bipyramidal. So it's upside, okay? 2 triangle we combine, so we can see 1 triangle on top and 1 triangle the other end on the bottom. So it's like trigonal bipyramidal, right? So what we're going to look into this shape is, we're going to see in these 5 pairs of electron, how many bond pairs, how to find how many bond pairs and lone pair. Very easy, right? So in central atom iodine, there are 2 iodine bonded. So that means 2 bond pair. Okay, 2 bond pair. And out of 5 pairs of electron, 2 is the bond pair. We need to minus that 2 bond pair. Alright, and we have 3 lone pair. Clear? Alright, I repeat again. First we find the total number of pairs of electron, 5 pairs of electron, and then we need to find how many bond pairs are there. How to know how many bond pairs? Look at the iodine. What is the number of iodine atom bonded to the center? 2 iodine atom. That means you have to minus the 2 bond pair. 1 iodine is 1 bond pair, 2 iodine is 2 bond pair. So we're going to minus into the total pairs of electron with 2. So we're going to get 3 lone pairs. So what we're going to do next is, we know that it is trigonal bipyramidal, and we know that it has 2 bond pair and 3 lone pair. So 2 bond pair and 3 lone pair comes under linear shape. Okay, it comes under linear shape. So how does the linear shape looks like? So first we're going to write iodine in the center, and linear shape is basically, it gives you a 180 degree in a planar shape. So it will be iodine and iodine on the other end, okay, up and down with a negative charge outside, because this negative charge is to the entire molecule, right? And what we're going to see, this is the linear shape where it gives you 180 degree, right? It gives you 180 degree from I to I and another I. So it sits in the same, on the same plane, in vertical line, right? This is what we call as a linear shape. Why linear shape? Let me explain. Because always remember, the bond pair, the lone pair, will try to occupy the equatorial position. What is the meaning of equatorial position? Don't forget that this I3 minus molecule, it has 3 lone pair, right? These 3 lone pair will occupy the equatorial position, whereby it's on the same plane, right? So it will be like this. It is very difficult to draw this, but let me put it this way. This is the center. Yeah, so I put it this way so that you can easily visualize how does lone pair of electrons occupy themselves at the equatorial position. Okay, you have one I here, another I here. Okay. One I at the upper position, in the middle, and one at the bottom. Okay, so this is the linear position. If you look at my molecular shapes of triiodide ion, you can see these are the equatorial position, the triangle where your lone pair of electrons are located. Okay, why this lone pair of electron is occupying the equatorial position? This is because to minimize the repulsion among themselves. Okay, so that they have a larger space to sit and to minimize the repulsion, so that this molecule can occupy the linear shapes at 180 degrees, right? So I believe this lesson gives you more understanding, and we shall see in the next tutorial session. Please don't forget to subscribe my channel for more updates. Thank you. See you soon.